Hi everyone, welcome to the Arcserve RPS Datastore Deduplication and its best practices. My name is Upendranath Nagilla and I'm working for Arcserve as a senior support engineer. So let's start today with the agenda where I'll be teaching about the RPS Datastore overview, data deduplication, practices to follow while creating Datastore. We'll also discuss about the deduplication and its best practices. And at the end of the session, we'll discuss about the benefits of data deduplication. To learn about the deduplication, first we'll learn about the RPS server. The RPS is a centralized backup destination, which means it is used for to store the data of your all servers in the organization, like Exchange server, SQL server, file servers, or any clients. So this will be the main backup destination used for the backups. And the prerequisites for the RPS server is any server which is 2008 R2 or above, and it is good to have RPS server installed on a physical server. The RPS is a small component which comes along with the agent. So without an agent, you cannot have a RPS installed on that machine. And the RPS server is consoled or managed by the UDP console. Let's take a small overview about the RPS. The RPS is offloading your resources of the source nodes, or I would say source servers, once the backup job is done, which means after the backup is done, all the other jobs like replication, copy recovery point, merge jobs, cataloging, all these jobs will be done on the RPS server itself, which means the source node is not involved when UDP is doing these activities. And to achieve deduplication, you need to have a recovery point server where you'll be installing the data stores, which could be non-dedupe or dedupe. It is also helping you to replicate data from one site to another site. So this is a small visual image of RPS server, how it is and how the data stores are installed on it or configured on it, whether it can be a dedupe or non-dedupe. Now inside the data store is where all the data is stored. We call it as recovery points. So each time when you do a backup, it is creating sessions and it will stored on the data store. Now let's see where you can configure the data stores. You can configure it on a local drive, which means it can be on the RPS server itself, or it can be any shared drive. Using a UNC path, you create a data store and you select the destination as a shared drive. Or you can also have storages like SAN, NAS. You can configure it as UNC paths or iSCSI targets and keep those as destinations for the data stores. Now let's see how deduplication is doing. You're protecting a node and UDP is doing a block level backup. Now what deduplication is doing is it is gathering all these blocks into one dedupe block. And now it is going to keep those blocks in different size, which can be 4K, 8, 16, 32 or 64. depending on the deduplication required. Now for those dedupe blocks, it is going to generate a hash for each data block, and it is going to store on your recovery point server, which is on the data store, which is nothing but the hash destination. Now when the hash sees that it does not already exist, then the data is copied to the data folder and it is creating an index for that data. And when the hash sees that it already exists, it is not copying the data. It is just generating the index, which means there is a deduplication. The block already exists, so it will not copy the same block. Instead, it is going to create an index for it. Index will help you to locate the actual data at the time of browsing or at the time of restoring. Now let's talk about best practices while creating data store, a dedupe data store. So what all things I need to go through before creating the data stores. So data store has data, index, and hash, which is helping us to dedupe the data deduplication. So the data destination is nothing but it defines the data destination folder to save the actual unique block. You have to use the largest disk to store the data as it contains. Now it again depends on what block size it is used, a small block or a bigger block. And for all the data, index, and hash, the folders should be empty. At the time of creating data stores, they should be empty. Now index destination. It defines the index destination folder to store the index files. As we understood how the indexing happens, it is pointing towards the actual data. So all this information is stored in the index destination. It is recommended to use index on a different disk to improve the performance or improve the deduplication. The hash destination. This is the place where all the hash algorithm is happening, and it will be good if you have the SSDs or you have the more physical RAM. What are the advantages in having pure memory and SSD? We'll talk in the next coming slides. If you have a SSD disk, please select that option called the hash destination is on a solid state drive. Memory allocation. This is the place where you'll be assigning the memory, whether it can be a pure memory or the SSD. Now, while selecting the dedupe block size, there are tools inside the UDP console itself which will help to plan before creating the data store. The estimator tool will help you to input some amount of the data. Based on that, the deduplication percentage estimation will give you how much disk space I need and how much memory I need. To the right hand side, you will see the screen when you start the option called enable deduplication. Here we need to mention the data store name, data store folders, which means the backup destination path, and for data, index, and hash. You can also select the compression and encryption, which we'll be talking in the next coming slides. Now there are additional tools apart from the estimator, which is inside the data store. There are online links where you can input the amount of data which we are going to store. Let's take one example. So here there are two sets of blocks, and we are going to mention 10 terabyte of source data. Difference in block 4 and block 32. With estimation of 60% deduplication and 30% compression, it says for 4K block size, you need to have 3.6 terabytes. With 32K block size, it is 5 terabytes, which means the bigger the block is, the more storage we need, which means the deduplication is less. At the same time, the hash memory, which is the physical RAM, the requirement for 4K block size is more than the bigger block 32. But with SSD, the smaller block 4K requires 2.5 GB, whereas 32K block requires only 500 MB. This is the physical memory, the pure memory, which is mentioned if you are choosing SSD as the hash destination. Now there are other tools comes with the UDP installer, which is located in C Engine Bin Tools RPS Planning. What this tool does is it will help you to input the machines which you are going to protect, and this tool is going to calculate the data of those machines, and at the end in the reports there is the option to select different block size, and UDP tells you what is the hard disk you need and the RAM with SSD and without SSD. These tools help to plan before creating data store. Now let's talk about the difference in physical memory and the SSDs. If I have physical memory, configure the hash destination on the RPS server itself. To use deduplication data store, ensure your recovery point has enough memory. Let's take example of 1 terabyte of unique data. If the deduplication ratio is 50%, then it is going to store 2 terabytes with 4K block size, and the estimation memory for this is 8 GB, which is the physical memory. And whereas SSD, if there is a SSD disk, create hash on same SSD itself and choose the option in the data store which says hash destination is on solid state drive. And for SSDs, the memory of the physical RAM is minimal. As we saw in the previous slide, it takes 500 GB for 32K block size for backing up 10 terabytes. Now, best practices following to create data stores. The continuation after the data index and hash and selecting the SSD. UDP also provides the encryption, and it is advanced encryption standard algorithm which is used for the encryption. You can either choose encryption or no encryption. The encryption password will be editable only when the option is checked. And the password is editable, which means you can change the password in future. But remember, the old password will be still used for the old recovery points. Compression. We have standard and maximum compression. This compression is often selected to decrease the usage of the disk space. But at the same time, it will also have impact on the CPU utilization. So based on the requirement, we need to select the different methods of compression, standard or maximum. Or you can also disable the compression. Concurrent active node. Specify the maximum concurrent active jobs on the data store. There is no limit in concurrent active nodes. This option allows you to run jobs at the same time. If it is 4, then it is going to have 4 active jobs. There is also option called send an email alert when a destination is nearly full capacity. This helps to get an alert when the data store is almost full. So at 90%, 95%, it gives you the alerts. Now the dedupe data store consists of 4 folders. 1, a backup or common folder. 2, data folder, index, and hash. For better performance, configure the data on a different volume or disk array, an index and common folder or backup folder on different volume or disk array, and hash on another volume, depending on the SSD or the pure memory. Configuring these data index on different disks and volume is majorly important for the big organizations where they store more number of servers. But if there is no resources, a single volume can also be used, and we can configure data index backup on same volumes. Again, after depending on SSD or pure memory, we'll choose different volumes for hash. But if you do leverage SSD, it is recommended to have hash only on that SSD disk, and all other destination paths should be on a different volume. If there is no SSD, like we discussed, we can have all volumes, all folders in one volume, or for better performance, for bigger organizations, if there is possibility, use different disk volumes for data and index. Purge and disk reclamation. The purge process will help us to retain the disk space. The backup job runs and it has to retain at some point depending on the retention policy. But after that retention is met, UDP is going to merge those recovery points. Now all these sessions which are merged, the purge activity is going to take place, which helps us improve, get more disk space. Merge is just deleting those sessions, and purge is the actual job which will run in phases in order to gain the disk space. So when does this job occurs? Whenever there is a merge job finished, or if there is any backup or replication job failures. Also, it runs every 6 hours. When there are no active jobs in the UDP, the purge jobs kicks off. Now there are two major phases in the purge activity, which is identifying absolute data blocks. This phase, it will identify those blocks which are marked as to purge after the merge job is finished, and it is going to gather all these files, and in the next phase it is going to delete those references or data files. So identifying absolute data blocks is to query and decrease references numbers to those files marked as to purge. Meanwhile, if the reference number of one block becomes 0, this will be marked as whole. This is the activity happening in phase 1. The next phase, which is disk reclamation, it is going to identify those holes, and that's when the data space is available. The below screen will be updated in the UDP console activity logs. Like the purge maintenance has started, the phase 1 is identifying absolute blocks, phase 2 disk reclamation, and then it is going to clear those disk space. These events are reported in the UDP console activity logs. By default, the purge process would automatically suspend the regular UDP jobs. When the purge starts after the merge activity or after 6 hours or for any job failures, it will trigger the purge job. But again, it will have to stop if there is any active job running in the background. This is to avoid the identifying absolute data blocks, and disk reclamation impacts the throughput of the regular UDP jobs. Now once the job is finished, again the purge is going to start, and it will do the phase 1 and phase 2. In fact, it will resume the activity. Now there are some organizations who run jobs day in day out, so the purge job is not going to run. In those cases, there is an option to run this purge activity along with other UDP jobs. But as it said, it is going to have impact on the resources. Now that we learned about how to create, or what are the best practices to understand before creating data stores, let's talk about best practices to avoid any data loss or corruption. So as we know, the data store can be created on local disk or shared drive or storage. Do not unplug these devices when the data store is in running state. The files which are required the important files may get corrupted or may get deleted when we are doing this activity. Also, it is important to have exclusions set in the antivirus. These antivirus will not only scan our data files, there are chances that it can also quarantine these data files. So even the scan will reduce the process when there is any job running. So the antivirus exclusions, we have this information in the guide. Let's see this. So these are the list of UDP processes which needs to be excluded. So these are the lists for the RPS where the data store is saved. And exclude the backup destination files, which means the data store path, data index hash, and backup. Perform regular health check on the disks which are configured as data store destination paths. Whether it is the storage or the local disk, do check disk, run diagnostic tools on the storage to make sure the disk is clean. If you do not have the SSD disk, do not select the option hash destination is a solid state drive. Only when the SSD disk is used for hash, that's when you will select this option. Do not enable any kind of Windows compression or Windows deduplication because UDP is already doing the deduplication and compression. By enabling these options, will add more performance or utilization of the disks. Whenever you see disk related issues or network related issues in the Windows event logs, analyze them. This will help us to isolate the problems to disk related, which in turn can corrupt the data store files. Also, backup destination servers like RPS server or the storage itself. If there are any frequent reboots happening, unexpected shutdowns due to power failures, address all these issues and fix them. Do not move, delete, rename, or replace any files manually. Once the backups are done, if there is any need of deleting these nodes because the node has been decommissioned or it is not required in the future for the restores, then perform this activity only from the UDP console by browsing the data stores. Let's see the steps of deleting the node. So from the UDP console, the resource tab and recovery point servers, browse the data store and select the particular node which needs to be deleted. and click on Actions or right click on the node and then select Delete. So as soon as the node is deleted, it is not going to immediately reclaim the space because it is on the deduplication data store. It has to go through the merge and the purge activity. That's when UDP is going to reclaim the disk space. Deleting this nodes manually will not be included in the purge cycle because it was not deleted from the console, so the data store will not know which blocks it has to delete or it has to mark as whole or zero. So those kind of data will be orphaned. When the hash path is full, whether it can be SSD or a local disk which is using a memory, but when there is a need of moving the disk space, moving the hash to another disk, the bigger disk, we need to follow the best practices. Now let's see those. So these steps are, if you are changing from the physical RAM to the SSD disk, when you switch from the RAM to SSD, you would need less memory. So UDP will automatically decrease the minimum value of hash memory allocation. However, you can manually change hash memory allocation. For this case, you change the hash destination folders to SSD. When you change the destination to hash, UDP automatically copies hash files to the new location on SSD. At the same time, when you're switching from SSD to physical RAM, we need to go back to the estimator and check the values because earlier it was an SSD and using minimum RAM. Now it is switching to the physical RAM, so it needs more memory. So let's see how modifying the hash destination. So when the only hash path destination has to be changed, we need to create new hash folder, and in the data store hash destination, mention the new hash folder so that UDP itself will modify and copy those files. So manually moving the hash files is not required, and it is a best practice to modify it from the UDP console itself. Now, not only the hash destination, if there is a need of expanding the disk and it is required to move data, backup, or index destination paths, we need to take some precautions. Let's see what are those. So the first step is to stop the data store. Before you stop the data store, make sure there are no active jobs like backup, replication, or any restore jobs, and then stop the data store. Modify the destination path and point the destination to the different data stores or a shared folder. Select the checkbox, pause this plan, and save the plan. The reason we are doing is we cannot delete the data store if the data store is used by any other plans. So for temporary reason, modify each plan which is used by this data store and select a temp destination and pause the plan so that it will not run any jobs to the temporary destination. Now delete the data store. The fourth step is copy all those files to the new destination, and once the copy is finished successfully, make sure all the files are copied. Now come back to UDP console and import the data store with the new data index or destination paths. Now you can start the data store once the new destination path are all mentioned, and then you can go back to the plans and select the data store as destination, and then you can start the backups. So the same thing applies for the data or index or for any other destination path. UDP also recommends to use 3-2-1 scheme, which means we keep 3 copies of the same data, which can be 2 copies on a different media, which can be a cloud or copy to tape. 1 copy is on a data store, so the other 2 copies can be replicated to Oxo Cloud or to the Oxo backup. And one of them can be offsite or offline or remote site. So 1 copy on the local site and having a different RPS server on another location. This will help if the site level disaster happens, we always have another copy. This will also save us from the virus like ransomware. Now let's talk about the data deduplication and its benefits. With all this deduplication and compression, we are saving a lot of disk space, which means there is a possibility of protecting more number of machines or more data. While doing the backup, the UDP is sending only the unique blocks. So in that way, we are saving the amount of data traveling through network. With UDP global source side deduplication, we are avoiding the backup, duplicating the backups. With global deduplication across all the clients in the infrastructure is central to limiting to unnecessary storage and transfer of deduplicate backup data. For replication jobs, UDP is sending only the unique blocks, which is helping us to save the bandwidth. And the deduplication is across nodes and jobs. UDP is doing deduplication at the time of backup job itself. which is called source side inline deduplication. And at the time of replication, it is sending only the unique blocks by saving the bandwidth, which is helping to save the bandwidth. This is the setup of one of our client who is having multiple data stores. So if you see, UDP is helping with deduplication and compression. The overall data reduction is more. So for some data stores, storing 171 GB with 54% deduplication, the space occupied is only 79 GB. Also with 92% deduplication, we are able to store 9 terabytes. We are able to protect 9 terabytes by using only 700 GB of disk space. So thanks to UDP for giving deduplication and compression. Because of that, overall data reduction percentage is high, which is helping us to get the disk space and store more data. So that's it from this session. If you have any questions, we'll answer them. You can post your questions in the chat. So we have few questions here. I'll read them through. Since only one copy of data block is stored in the data store, what happened if the data block is corrupt? Okay, to answer this question, whatever the corrupt block has reference to any node or any particular session, only that node or the session recovery point is corrupt. So we can still be able to restore from other recovery points. Yes, we'll share the copy of this slide. It will be posted online. Can I configure single job for VMware and physical servers? No. For agentless backups, you protect only agentless VMs, but for the agent based, whichever machine, it can be physical or virtual, that has to be backed up only on agent based backup plan. Manual backup retention period, how much can I define? By default, the custom and manual will be 31, but based on the requirement, you can increase more. What is size of SSD disk? It depends on how much data we are backing up with how much percentage of deduplication. So use those estimation tools which will help you to know how much SSD disk we need with different block size. Ratio of deduplication is always depending on the nodes and the data we are protecting. If you saw the previous slide, different data stores are having different deduplication percentage. So it is always dependent on the source uh, data or the kind of data which we are backing up. What is the block is from the first backup session that is corrupt, which means the full session, the baseline itself is corrupt. There are chances we can restore partially. That's the reason we say you need to have those precautions to avoid these kind of corruptions, whether it can be because of the antivirus or it is environmental issues. If you take those extra care, or the slide where we discussed about the corruption and preventing the data loss, we can save the data. We can set up data store for some node without retention. Without retention is not possible. We cannot, yeah, it is not possible. To back up a server, is it the right job policy or anything required? Incremental backup policy, daily merge policy once in a week. You can refer the guide, the admin guide. Okay, so there's one question from Chris Evans. Um, what if session 5 is inconsistent, unable to read from session 5? So backup of job day 6 is not happening. Can we remove the set from the series? No, we cannot, or we should not delete the set 5. In fact, you can try reducing the retention to 4 and see if the UDP is able to merge the session. Otherwise, you'll have to do a full backup. Where the UDP agent can be installed, it is installed in each virtual machine inside VMware. It depends. If you want to protect your virtual machine as a agent based backup, that's when you'll install the agent. Otherwise, you can still backup with agentless. For UDP appliance, we already have uh, we took the precautions before shipping the appliance, so the data stores are pre-configured. And if you want to add more data stores, create the data stores on the same volumes compared to the old previous one. Usually it will be on X drive, backup, index, and data, and Y drive will be the SSD. So can I take backup of physical server, local drive, and LAN mount disk from storage like CD, local server disk, and SAN? As far as the SAN drive is presented with the drive letter, yes, you can backup and restore and perform BMR as well for all those three drives. On what scenario to create multiple data stores as dedupe and compression is per data store? Yes, deduplication compression is per data store. If one of my data store is 4K and without compression, then it will not do compression and it will do 4K deduplication. And the other disk is bigger block and maximum compression, then it will do maximum and less deduplication because of bigger block. Because some user need to have the backup until 2 years with custom backup 4 incremental and 1 day, but UDP max retention is 1440. Then you can have another data store and replicate it, and you can keep it as archived, or yeah, that will be the best practice. You can move the data from the primary to the secondary data store and keep it for the archive. UDP sessions can back up to tape using differential or incremental. Always UDP sessions with help of copy to tape, it will do a full backup. Yeah, Johnson, you can use data store on the same RPS server with new version 6.5 update 4. We have replication between data stores, which means you can have only one RPS server and multiple data stores, and still you can do replications. Can I take backup of RPS data store through Arxo backup? Yes, you can directly protect copy the RPS server data stores to tape. But yes, there is online guide also. The admin guide will help you to configure that. Okay, I hope I answered all your questions and this session was helpful. Thanks for joining, everyone. Have a nice day.